So this lesson is going to be on complex fractions, which we did briefly in class, but I'm not sure about the other sections. And it's going to be good review anyway to go over this because especially on the old Algebra 2 exam, they ask a ton of questions about complex fractions. So let's look at number 1. We've got 3 fractions within one big fraction, which is why we call it a complex fraction. And in part A, it's asking what the least common denominator is for all 3 of those fractions. So we have denominators of 9, 18, and 3. So the least common denominator for those 3 would be 18. So if we take that 18 and we multiply all the parts of the fraction by 18, it's going to do something kind of nice. Multiply by 18, by 18, by 18, and then the 18 over 9 will cancel to a 2, or simplify to a 2 rather. 18 over 18 will cancel out. 18 over 3 will be 6, so we'll be left with 2 times 1, which is 2, plus 1 times 1, which is 1, over 1 times 6, which is 6. So we get 3 over 6, which is a half. And I mean, for something like this, you could have, because they were all numbers, just put this in your calculator using the alpha y equals button. You'd need to make a fraction, and then within that make other fractions, and add all of these up, and the calculator would give you 1/2 as the answer. But it's not always going to be all numbers. So now in part C, why is it acceptable to perform the operation we did in B? Well, why can we multiply everything by 18? Because really, we're multiplying the numerator by 18, and the denominator by 18, which is the same as multiplying by the number 1. So that's why we can do that to the numerator and denominator. So let's look at number 2. Got a bunch of complex fractions here. Again, 2a is all just numbers, so you could just throw that in your calculator. But the other ones we're going to need to not use the calculator for. So let's look at 2a. The common denominator between 2, 10, and 5 would be 10. So I'm going to multiply everything by 10. So this will cancel to 5. This will completely cancel out, and this will cancel to 2. So we'll get 5 minus 1 over 2 times 2, which is 4. 4 over 4, which is 1. Common denominator in B, we've got a 3, an x, another 3, another x. So the common denominator is going to be 3x, 2 of them together. So now the 3's will cancel, the x's will cancel, the x's will cancel, the 3's will cancel. And we're left with x times 2, or 2x, plus 2 times 3, which is 6, over x times 5, 5x, plus 5 times 3, which is 15. But this one has even an extra kind of element to it, because we can simplify this fraction. We spent the whole unit simplifying, multiplying, dividing, adding, subtracting fractions like this. And anytime we did this, we had to factor first. Well, the numerator has a GCF of 2, the denominator has a GCF of 5, but when we factor, they both have x plus 3, so our answer is 2/5, which is pretty nice. I don't know what happened to my problem C. My fraction bars went away, so I'm going to write those in. And when I multiply this one, let's see, my GCF, or my common denominator rather, is going to be 8x. So let's multiply everything by 8x. And that will take the 8's, cancel them out. 4x and 8x would be 2. 8x and 2x would be 4. 8 and 4 would give you a 2, and the x will still be there. So x times 3 is 3x plus 2 over 4 times 7, 28, plus 3 times 2x, which is 6x. Now with this one, 3x plus 2 can't be factored any further. Maybe the denominator gives us a factor of 3x plus 2. Let's look at it. 28 and 6 don't have any common factors, so that can't be factored either. So that's going to be your answer in simplest form. So for that one, we couldn't actually factor and simplify. For B, we could. Sometimes you're going to be able to, sometimes you won't. Okay, let's look at number 3. Again, all my fraction bars are gone. This is interesting. Let me write these in. So for 3a, common denominator, there would be 2x squared. So let's multiply everything by 2x squared. So that's going to cancel out the 2's, cancel the x squareds. 2x squared over 2x will leave you with just an x, and cancel out the x squareds. So x squared times 1 is x squared, minus 2 times 2, which is 4, over 3 times x, which is 3x, minus 3 times 2, which is 6. And then these can both factor, x minus 2, x plus 2, and 3 times x minus 2. And now what's nice is these cancel out, and our final answer is x plus 2 over 3. So I'll give you guys a second to try 3. If you want to pause the video, you can. But I'm going to write the answer down for you. We're not going to do 3b. You guys can try that one on your own. But your answer will be 2x. So if you pause the video and tried it yourself, hopefully that's what you got. Let's go to C. And again, let me draw my fraction bars in. The only reason I want to do C, it's really not much different, but there's 3 fractions in the numerator. Shouldn't really confuse anybody, but we'll look at it just in case. 12, 6x, 12, and 3x. We need a common denominator between all of those. So that's going to be 12x. We need to make sure that we multiply every single part of this by 12x. So the 12s will cancel. 12x over 6 will be 2x. Here the x's will cancel. This will be 4. And here the 12s will cancel. So we have x times x, which is x squared, plus 1 times 2x, 2x, minus 2 times 12, 24. Over x times x, x squared, minus 4 times 4, 16. And you can factor both of these, hopefully really quickly. By now, this stuff should be really easy. Definitely the denominator really easy. Numerator, let's see, adds to 2, multiplies to negative 24. Positive 6 and negative 4 would work. So now the x minus 4's cancel out, and your answer is x plus 6 over x plus 4. So really not that bad. After you find the common denominator, multiply all the terms by that common denominator, and then from there you're just simplifying. Now number 4 gets a little trickier because the fractions we're working with are a little more complicated. But in general, 4a and 4b are very similar problems. And I think what will help you with 4a and 4b is factoring the denominator of the bottom fraction. And in this case, I mean the x squared minus 2x minus 8. That's actually x minus 4, x plus 2. So rather than looking at this, we'll think about it as x minus 4, x plus 2. And now it's easy to see, this has x plus 2, this has x minus 4, this has both of them. So we're going to need to use both of those as the common denominator. So here we can multiply by x minus 4 and x plus 2, x minus 4 and x plus 2, x minus 4 and x plus 2. And in B, I'm going to do that in a little bit shorter way, save us a little bit of time, but for now we'll keep going this way. Cancel those, cancel these, cancel everything. So now we've got 4 times x minus 4 plus 2 times x plus 2 over 12x minus 24. We have some distributing you have to do. 4x minus 16, 2x plus 4 over 12x minus 24. And then 4x plus 2x is 6x. Negative 16 plus 4 is negative 12 over 12x minus 24. Factor. Factor. These cancel out, and 6 over 12 can simplify to 1/2. So that whole big problem simplified down to 1/2, which is kind of crazy. Alright, let's look at the last one quick. Again, factor the denominator, it'll make your life a lot easier. X plus 6, x plus 2 is the factored form of that. So rather than using that, let's use that. So the common denominator here is x plus 6, x plus 2. But rather than writing it 3 times, I know that when I write x plus 6 next to this first fraction, it's going to cancel with the x plus 6 I just crossed out. So the only thing left over is the x plus 2. Similarly here, the x plus 2's will cancel, and the only thing left over will be the x plus 6. And then here, everything will cancel with everything that was there. So now we're left with x times x plus 2, which is x squared plus 2x. You got to be a little careful here if you use these shortcuts. Negative 1 times x plus 6, so negative x minus 6 over x squared minus 4. Combine your like terms, x squared plus x minus 6 over x squared minus 4, factor. Positive 3 and negative 2 would work. Over x plus 2, x minus 2, and then these cancel out, and I'm going to be a little lazy and just circle that as my answer. Alright, so x plus 3 over x plus 2 would be your final answer. But in general, these complex fractions look much more complicated than they are. Just find the common denominator, multiply every part of the fraction by it, and then simplify your answer. That's it.
Those that you